Okay, look at what these problems actually say. It says this function, this function right here. Where is this function greater than 0? Where is it greater than 0? So here, I'm just going to draw a quick one really fast. Where is this line that I just drew greater than 0? Between A and B. So all of these numbers give me y values that are greater than 0. What's another way we can say this? What's another way I can say this instead of saying greater than or equal to 0?
X is greater than or equal to 4, but less than or equal to 1.
Okay, you said the same thing that already says. I want to know graphically. And graphically, I could just say, where is the line of this above the x-axis? Did you guys hear what I said?
Yeah.
Where is the function above the x-axis? That's pretty much what this is saying. Where is the function above the x-axis? That's what this one's saying too. Where is this function above the x-axis? Oh wait, it says equal to. That means it's saying, where is it above and where is it on the x-axis? So I'm going to do this first one really fast because it is relatively simple. Okay, what are our x-intercepts for this one? It looks like 4 and 8. Okay, now does my function go like this or does it go like this? The smiley face? How do we know it goes up? Because it's a positive. Like if I multiply this out, it's going to be x squared minus, what would that be, 12x plus 32. Look, the leading coefficient is positive. So because the leading coefficient is positive, I know we go up. So where is this function greater than or equal to 0? All the numbers over here and all the x numbers over here. Because that's where the function is greater than 0. That's where this function is above the x-axis. So I'm going to write from negative infinity to 4. And I'm going to include the 4 because it's on the x-axis right there. And then from 8, I got to include the 8, to positive infinity. So that's the answer for that one.
It's with bracket.
Let's look at this one. This next one. Now this one we're going to have to graph. So we have a vertical asymptote at 1. And then, let's see, do we have a horizontal asymptote? Yeah, it's at 1 also. I know it's at 1 because my degree up the top is 1, the degree on the bottom is 1. Since the degrees are the same, we take the leading coefficients and we divide them. 1 divided by 1 is 1. So we have y equals 1. All right, so it looks like we're going to cross the x-axis either right here on this side or here right here. So I'm going to look for the x-intercept. To find the x-intercept, I'm going to take x plus 1 over x minus 1 and set that equal to 0. I multiply both sides by x minus 1. And I still get 0 on the right side. So I get x plus 1 equals 0, which means x equals negative 1 is an x-intercept. So I'm going to put a dot right there, which means this side of the graph goes something like that. I can confirm my y-intercept just by plugging in 0 to this. I would get negative 1, so it looks like that's a negative 1 right there. Where would the line be on this side? Would it be right here or on the bottom? It would be right here. And how would you know for sure? You would know for sure just by plugging in a number over here, like plugging in a 2. You'll know for sure. Now I'm pretty confident that it's up there. So where is this function above the x-axis? It looks like for all of these x values, including everything negative, so negative infinity to negative 1, bracket because it's equal to, and then all of this. So that would be from 1 to positive infinity. Does 1 get a bracket or does 1 get a parenthesis? It gets a parenthesis because it's a asymptote. All right, there's your answers for those.